Okay, rational numbers is the title of our chapter. And so we've been working with integers in our last chapter. Integers are a specific type of rational number. Okay, just like Chevy is a specific type of vehicle. Okay, so rational numbers are a large group of numbers. They include almost every number that you can possibly think of. Integers are a subcategory, like the chapter we just did with integers. And even within integers, we have a subcategory of whole numbers. Whole numbers are the numbers you guys first learn when you're, learning to count. Georgia, can you shut the door for me, please? Okay. Whole numbers are your counting numbers, starting with 0. Okay, you're all positive numbers. And then the integers include all the whole numbers and then also all the negative numbers. They're opposites. Rational numbers include all of these. But since we just did a whole chapter on integers, we're probably not going to focus on this as much as we're going to focus on these fractions and decimals. That's what I think of when I think of rational numbers. Okay. The actual definition of a rational number is a number that can be written as a ratio of 2 integers. Now, a ratio is a fancy way of saying a fraction. So a rational number is any number that can be written as a fraction. Most numbers that you've ever learned in your life can be written as fractions. 6 can be written as a fraction. How? Aiden? 6/1. In fact, I can turn any whole number or any integer into a fraction by simply putting it over 1, like -10/1, 4/1, 0/1. Fractions, of course, are already fractions. Mixed numbers can be written as improper fractions, so there's no issue there. Most of the decimals you've ever seen in your life can also be written as fractions. In fact, on your chapter 2 opener on Friday, you had 2 problems where they had you write those decimals as fractions. Okay? And if you didn't get that far, we're going to look at examples of how to do that today. You can also write repeating fractions or repeating decimals as fractions, and you'll actually learn about that next year, about how to do that. It's really, in some instances, very easy. In some instances, it's more complicated, but it's a pretty simple lesson that your teachers will do with you next year. Okay. So this leaves out only one type of number. Non-terminating, non-repeating decimals. Because if your decimal terminates, which means it ends, it can be written as a fraction. Like 1.5, we could say is 1.5. If the decimal repeats, I just said a repeating decimal can also be written as a fraction. So if you have a decimal that doesn't end, so it goes on forever, and it doesn't repeat, well, then now we have an irrational number. Can you think of an example of an irrational number? Branson? Pi. That's exactly right. Yeah, pi is probably the most popular of the least popular group, the irrational. Okay. We will use pi quite a bit after Christmas. But our first semester of lessons, we don't focus very much on irrational numbers, just on the rational ones. Yes?
I thought pi was like algebra.
Nope. Nope. Algebra would be solving equations, which you're going to do next chapter.
Why am I not?
Because you're going to be in algebra and they're going to introduce you into equations this year. Actually, you already did some last year too. So just,
do I have to take algebra next year?
No, not next year, but you'll have equations. See, algebra is just one form of math that deals almost specifically with equations. We don't really stick in one group for too much time. We do integers, then we jump to rational numbers, then we jump to equations, then we jump to inequalities. We just kind of jump around a lot in 7th grade. We don't spend too much time in any one particular category. Okay. All right. So the first thing I'm going to have you guys do, and by the way, I am going to ask you guys questions on what rational numbers are. So just remember that every number you've seen is a rational number except for pi and any numbers like pi. So if you think of pi being irrational and it goes on forever and there's no pattern to it, it's exactly what we're looking at. Now, since we've also talked about square roots this year, what's the square root of 9? 3. Is 3 a rational number? Can you write it as a fraction? Yeah, it's a nice number. It's a whole number. So is the square root of 9 a rational number? Yeah, because it's 3. What about the square root of 10?
Yes.
What's the square root of 10 equal to? the square root of 25 is equal to 5. See, remember we talked about perfect squares? The reason we talked about perfect squares is because when you square root them, you get these nice perfect answers, what we call these whole number answers. If you square root any number that's not a perfect square, you end up getting a very, very long, non-repeating, non-terminating decimal. So anytime you square root a non-perfect square, it is going to be irrational. There's my abbreviation for irrational. Okay. Your first 12 perfect squares I've got up here on the clock. Square root of 64, it's 8. Square root of 65, irrational. And we're not going to talk about it this chapter. Okay. You can do it. There is a number for it. It's just 8 point something forever. It looks a lot like pi. It's just a bunch of random numbers after the decimal point that go on forever. So we're going to focus today, since your guys' chapter 2 opener had you do this, we're going to focus today on writing fractions as decimals and writing decimals as fractions. So to write a fraction as a decimal, we're going to do top divided by bottom. Top divided by bottom. So in this first one, it says write each fraction or mixed number as a decimal. The top number, that's the number that we're dividing into. That number is going to go inside the division box. The bottom number is going to go outside the division box. Now, I know you guys can do long division. The problem we run into most often with writing fractions as decimals is I'll get students that do this. Pretty common mistake. What did they do wrong? Say it, that's right. They put the bigger number inside, which 90% of the problems you've ever done, the bigger number has been inside the division box. So I get it, but that's not the rule. And math is all about rules. The rule states that the top number goes inside. So we have to put the 3 inside. And I know it doesn't look natural, but that's okay. Think about what kind of answer I'm supposed to get. I'm supposed to get a decimal answer. It's not going to be nice. So don't expect 3 to be able to go into 8. It's not going to. That's that. By the way, how many times does 3 go into 8? Twice. Is there a 2 in front of this fraction?
No.
No. So I can't do that. I can't do that. Okay. If I set it up that way, that would be me doing 8/3. That's not what it says. So because 8 does not go into 3, and that's why you probably are like, well, that I would have done it the other way. And that's why a lot of people do. Because 8 doesn't go into 3, I'm going to put a decimal and I'm going to put a 0. That's just perfectly legal. I'm changing 3 to 3.0. And I'm going to put that decimal right up there on top of my answer as well. Now, instead of doing 8 into 3, I can do 8 into 30. Maddie Yentes, tell me how many times 8 goes into 30. That's 32. It's 3. What's 8 times 3 equal to? It is 24. Yep, so we're going to subtract 30 minus 24. We're going to get a remainder of 6. I don't want to have any remainder at all. So if you get a remainder, that means we need to drop another 0 down. And we're going to make this a 60. Georgia, how many times does 8 go into 60? That's right. What is 8 times 7? 56. Now notice where I'm putting the digits up in the answer. I'm putting them right above the zeros that I've been placing. Right, so I'm not. It gets difficult to do long division if you're a sloppy writer. So we want to make sure we're trying to write as nice and neat as possible. We're going to subtract 60 minus 56. We're going to get 4. I still don't want a remainder, and I have one, so I got to drop down another 0. Maddie Cheeseman, how many times does 8 go into 40? What is 8 times 5? It's exactly 40, so we're done. If you want to go ahead and continue it, you can put minus 40, 0, or you can just stop and say I'm done. Either way, we're going to get 0.375. Is there anything in front of the fraction? No. So there should be nothing in front of the decimal, unless you write the number that means nothing. 0. You could put a 0 here, and you could say 0.375. That's fine. If you want to leave it at just 0.375, that's also fine. I'm okay either way. I'm going to shrink this out of the way. Move on to the next example. Now, some of these fractions, I know that you guys did last year. Like I know that Mr. Tuberty and Mr. Miller, when they worked with you guys on fractions, they had you guys memorize some of them as decimals. Your fourths were probably one of the categories they had you memorize. Does anyone remember what 1/4 is as a decimal? Aiden? 0.25. That's right. Because 1/4 is the same as a quarter. And a quarter of a dollar is 25 cents. So 1/4 or 1/4 is going to be 0.25. So if you already know that, then this became super easy for you. Now, last time we didn't have anything in front of the fraction. This time we do. This is easy. Anything in front of the fraction just goes in front of the decimal point. And vice versa. It's super easy. Anything in front of the fraction goes in front of the decimal point. It's the fraction that we have to convert into a decimal, and Aiden's just told it to us. It's 0.25. Now, how many of you forgot that from last year? Okay, that's okay. Because if you forget, you can still do top divided by bottom. And I know that looks weird. 4 and the 1, why would you do that? Because 1 is the top number. The top dog gets the house. Did you hear that last year? Top dog gets the house.
No.
You didn't hear that last year?
No.
Everyone in my last period class said that. That's what they heard from the math teacher said. Well, I'm saying it now. Top dog gets the house. The number on top is what you put inside the division house or the division box. Okay, really?
So like, I don't do like that. I did box methods.
I mean, you can't. I'm not going to tell you how to do it. I'm just telling you this is probably the easiest way to do it.
That's what the mom keeps saying, but I don't understand.
Okay, so we're going to put the top number inside the box, bottom number outside the box. The bottom number, the 4, is the number we're dividing by. So does 4 go into 1? Nope. So what I'm going to do is I'm going to make 1 into 1.0. 1.0 is the same number. So I haven't changed the problem, but what I've allowed myself to do is now do 4 into 10 instead of 4 into 1. How many times does 4 go into 10? Okay, so before I write the 2 down, I always float the decimal point up to the top because I want to write it in my answer as well. And I'm going to put the 2 right above the 0 in that 10, because if I would have put it here, that would be saying that it went into 1 twice, and it didn't go into 1. So if anything, you should put a 0 there. Okay. Now the reason I'm not going to put, or an X, I've seen some people put an X there as well. The reason I'm not going to put a 0 is because I know there's already going to be a 2 because of the problem had a -2 in front. Okay. So because it goes in twice, what is 4 times 2, by the way? 8. I'll write the 8 underneath, and I'm going to subtract to get my difference. What's 10 minus 8? 2. I'm done when that number I subtract gives me a 0. I don't have a 0. So what I need to do is I need to drop down to 0. Now it's a 20. 4 goes in the 20 exactly 5 times. So I put the 5 right above that 0 just placed up there. 4 times 5 is 20. I get a remainder of 0. I'm done. So 1/4, there's proof, since Aiden already knew it, but some of us didn't. 1/4 is 0.25. 0.25 is not my answer though, because this work that I got right here was just helping me do this part. Don't forget there's a -2 in front of the fraction. So a -2 is going to go in front of my decimal, make it -2.25. Okay. So if 1/4 is 0.25, what's 2/4? 0.50 or 0.5, since 2/4 is the same as 1/2. My guess is you probably memorized that 1/2 was 0.5 last year. What's 3/4? 0.75, 3/4. Did anyone memorize their fifths last year? Yeah, what are they? That's right, 0.2, 0.4, 0.6, 0.8, and then 1.0 for 5/5, it's just 1. So you're counting by 2s. If you have some of these memorized from last year, or if you can remind yourself of these different ones, you can save yourself some time. And if not, then just do your long division. Let's look at example C. Example C, now something a little bit different about this example, this fraction is improper. Normally when we see a fraction, the top number is smaller than the bottom number. That's called a proper fraction. An improper fraction, the top number is bigger. Improper fractions mean that that number is larger than 1. So if it's larger than 1, there's going to be something in front of my decimal point, not just a 0. So I put the bigger number inside the division box.
No.
No. In this example, the bigger number is going to go in the division box. Can you tell me why? Georgia? Yes, it's the top. The rule does not state that the big number goes inside. It states that the top number. If the top number just so happens to be the bigger number, so be it. That's fine. But it's always the top number. That's right. If you get these problems wrong, that's the first thing I'd have you check. Did you set it up properly? And I know that's going to frustrate you because you're going to set it up and you're going to be like, oh, I have to do all this division over again because I set it up wrong. Okay, so make sure you're setting it up right. Top dog gets the house. Does 5 go into 6? The answer here is yes, because this is an improper fraction. It's going to go in 1 time. That's going to be 5, and it's going to subtract to get 1. And then I need to put a 0 down. But before I put a 0 down, since I'm out of decimal or out of digits, I'm going to put a decimal point and put a 0. I don't want to make it 60. I want to make it 6 point up because I don't want to change this problem. Put that decimal point up in your answer. Then we can drop down to 0. 5 goes into 10 how many times? 2. Was there anything in front of our fraction? What? A negative sign, exactly, that counts. So I put the negative sign in front of my 1. So 6/5, negative 6/5 is the same as negative 1.2. That's going to be a really another way that you could get this one wrong is you could accidentally forget the negative. Now, there's another way you could do this one. You could actually convert this improper fraction into a mixed number. Since 5 goes into 6 1 time, that's our whole number, and there's 1 remainder. So 6/5 is the same as 1 and 1/5, negative 1 and 1/5. And if you're like Hannah and you have your fifths memorized, you would have known that 1/5 is 0.2, and immediately we could say this is just negative 1.2. So it's another way you could do that one without having to do long division. Turn it to a mixed number and see if the fraction looks more familiar to you. Like 1/5, we can do that. Is that what you're going to say? Or you had your hand up. Did you have a question? Stretching. All right, example D. Do you guys know your 11s from last year? Of course you don't, because nobody knows their 11s. Okay. All right. So that means top divided by bottom. 5 divided by 11, and not the other way around. The top dog gets the house. How many times does 11 go into 5? Yeah, it's not going to. Yeah, it's because we're going to get a decimal. So I just make it 5.0. Put that decimal point up in your answer. How many times does 11 go into 50? Thomas? 4 times. That's right. That's going to be 44. Subtract 50 minus 44, you're going to get 6. Drop down to 0. Because 5.00 is still the same as 5, so I haven't changed this problem at all. Parker, how many times does 11 go into 60? Okay, that's going to be 55. Good. And I'm going to subtract. I'm going to get 5. I'm going to have to drop down 0. And how many times does 11 go into 50? Branson? Yeah, I feel like I already asked that question, didn't I? So it's 4, and that's 44. And I subtract and I get 6, and I drop down to 0. How many times does 11 go into 60? Isn't that 5? What's happening here? It's repeating. If I could just write down a 6, that would be awesome. Yeah, it's repeating. It's just going to keep going on forever. And so what I can do, it's actually repeating the 4 and the 5, right? What I can do is I can just write this as, let me shrink some stuff out of the way here. I can just write this as 0.45 repeating. And then instead of putting 2 repeating bars, I'm just going to put 1 long repeating bar over both the numbers that repeat. Feel free to put a 0 in front of the decimal point if you want to. Just don't put the repeating bar over the 0. By the way, as soon as you know that the number repeats, go ahead and stop. The only reason I went on is just to prove to you that it was going to repeat. But as soon as you know it's going to repeat, go ahead and stop. Okay, put your repeating bar. Or you can do what they did. I wouldn't prefer this, but sometimes the book will write it like this with ... to show you that it goes on forever, following that same pattern. It's so much easier just to put a repeating bar than it is to try to write it out 6 times and then put ... Example E. Is there a number in front of the fraction? Yep, so it's going to go in front of the decimal. So it's going to be 1 point something. It's not the 1 that makes this challenging, it's the 4/9 that makes it challenging. I have to figure out what 4/9 is. Which number is going to go inside the division box? The 4. Yeah, the top number. Top dog gets the house. I learned my lesson last time, so I'm going to try to extend my division box a little bit longer. It's not bad. 9 doesn't go into 4. I'm not surprised by that. I'm looking for a decimal answer. So I put my decimal point. I make it 40 or 4.0. How many times does 9 go into 40? What is 9 times 4, Branson? Okay, so I'm going to put 4 up there. 36, subtract 4, drop down to 0. How many times does 9 go into 40? 4, 36, subtract 0, or drop down to your 0. It's going to be 40 every single time, isn't it? So once I know that this is just going to repeat forever, stop. Put a repeating bar. But it's not 0.4 repeating, it's 1.4 repeating. Don't forget that there was a number in front of the fraction, so I have to put that number, that 1, in front of my, oh, I said that backwards. No, I said it right. I have to put that number 1 in front of my decimal point. Yeah. Whatever's in front of the fraction goes in front of the decimal point. Did you guys say you had your halves memorized? There's only 1/2. What is 1/2? 0.5? What's negative 1/2 then? Okay. You can write negative 0.5. You can write negative 0.5. I don't care how you write it. What if you forgot that from last year? Can you do long division to figure it out? Of course you can. What number goes inside the division box? 1 divided by 2. By the way, that's not any different from what you guys did last chapter. Last chapter, you guys would have seen a problem like this. Is this not a fraction? It is. Did you do 24 divided by 6? Yeah. Yeah. How many times did 6 go into 24? 4 times, and you made it negative, right? So the only difference between what we did last chapter and what we're doing now is that 6 actually went into 24 a nice number of times. You got a nice answer, a nice integer answer, -4 for this one. This chapter, we're still going to do division. It's just 2 doesn't go into 1. 8 doesn't go into 3, so on and so forth. So I have to do long division to figure out what decimal I'm going to get. So since 2 doesn't go into 1, I make it a 10. How many times does 2 go into 10? There's my 0.5. And there's something in front of the fraction, so I make it -0.5. Questions on that? That's my least favorite part, is turning the fractions into decimals. That's my least favorite part because of all the long division. My favorite part, if I had to choose a favorite, would be to go the other way and to write my decimals as fractions and go backwards. To write decimals as fractions, write the number over its place value. Now, even though I think this is the easier of the two, it's the one that everybody seems to forget. So here's what I mean by that. And I'm going to fill in that second blank in just a moment. Here's what I mean by that. Any numbers after the decimal point, write them on top of their fraction. It said write it over its place value. So write it over on top its place value. What do we call the second decimal column? That's the first one. Hundredths. There isn't a ones column. There's a ones column, and then it goes tenths. Oh, never mind. I'm just not going to write it. It's too tiny. And then this one's the hundredths. That's right. So I'm going to write it over its place value. Was there anything in front of the decimal? A negative. So I put a negative, and there we go. It's a fraction. However, and that's easy, right? You can do that in just a matter of seconds. Where fractions become a little bit trickier is because fractions have to be reduced. So after you write it over its place value, you have to check to see if it can reduce. Is there a number that goes into 26 that also goes into 100? Yes. They're both even. So tell me what number goes into even numbers. Addie? 2. Yep. We're going to divide by 2. You don't need to show all this work on your paper. I mean, you don't have to put the divide by 2 on your paper. You just put an equal sign if you want to. How many times does 2 go into 26? Or think, what's half of 26? 13. And what's half of 100? 50. And don't forget there was a negative sign. Now it's reduced. Write the number after the decimal point over its place value. Next one. 7. That's the number after the decimal point. That's going to go over. What's this? What's that place value called? Tenths one. Yeah, the tenths is the very first one. So if you have one decimal place, it's the tenths column. Okay. Is there anything in front of the front of the decimal? Negative. So put the negative in front of the fraction and make it to where it's separated a little bit. In fact, I put this up here just to show you that you could put the negative in front of, on top, or on bottom, and it's not going to matter. To go back to that problem we just looked at when I had you do, when I said what's negative 24 divided by, I think I said 6. It doesn't matter if the negative's up here or if the negative's down there. We know one negative makes the whole answer negative, right? So it actually doesn't matter where you write the negative as long as it's there. You will see me more often than not write it in the middle, like that. Does 7/10 reduce? And if so, what number goes into both of them? No? Okay, so we're done. Sometimes they don't reduce. In fact, that's awesome when they don't reduce. Here, by the way, if you're wondering why we do this, you guys a long time ago, I want to say it's probably like 4th grade or whenever you get introduced to decimals. Do you remember when you had to write them out longhand? You had to write out the entire thing. Like for this one, you had to say 26 hundredths, right? You remember writing out longhand? We normally just say 0.26, but its actual name, if you call it by its full name, is 26 hundredths. Whatever its full name is, that's what you write. 26 over 100. This one, this fraction's full name would be 7/10. That'd be an easy one to write. That's what we write. Of course, it's negative. What would this one be? 5. What word do we put for this? And 5 and 125. That's long enough right there. Thousandths. Whatever its place value was, that's the number we write on the bottom. So is there a number in front of the decimal point? Absolutely. And just like last time, any number in front of the decimal point is just going to go in front of the fraction. Okay, that's super easy. The only part I have to figure out is what does 125 over 1,000 going to reduce to? So what could I reduce by? What are you for sure goes in? Hannah? 5. 5 goes in. Okay. We're going to divide by 5. How many times does 5 go into 12? Twice. With how many left over? 2. Put that 2 right there. How many times does 5 go into 25? 5. Any remainder? Nope. Okay, that's my top part of that. What I just did is I did long division without writing all the work down. It's like mental long division. How many times does 5 go into, it doesn't go to 1. How many times does 5 go into 10? Twice. No remainder. How many times does 5 go into 0? 0. How many times does 5 go into 0? 0. So I get 25 over 200. What can I reduce by now? 25. Okay. How many times does 25 go into 25? Once. How many times does 25 go into 200? 8. It goes in 4 times to 100. So it's gonna be another 4 times into 200, right? So it goes in 8. Don't forget, I'm gonna have to rewrite this one. There's a 5 in front, isn't there? And if you guys got to the point where you were able to memorize your 8s from last year, you would have known that 1/8 is 0.125 and vice versa. If you didn't memorize your 8s last year, we have to do some reducing, obviously. Okay. Is there a number in front of the decimal? What is it? What is it? -10. Don't forget the negative, right? Put your fraction bar. Write the 25 over its place value. What's its place value? Yep, second decimal column is the hundredths column. Now, you guys told me you memorized what 0.25 was. Do you remember what it is as a fraction? Hannah? 1/4. If you memorized last year that 0.25 was 1/4, you could just immediately just jump to 10 and 1/4. Don't feel like you have to write that. If you didn't memorize it, then you're going to have to write that and you're going to have to reduce it. And it reduces by 25. 25 goes into 25 once, and we just said 25 goes into 100 4 times. So you have to reduce it unless you already had it memorized. If you already had it memorized, you could jump right to the answer, negative 10 and 1/4. Example E. Is there anything in front of the decimal? Yep, so write it down. That's going to go in front of a fraction. It's going to be a mixed number, negative 3 and 1 over what? Does 1/10 reduce? What's it reduced by? No? Okay, we're done. Example F. Is there anything in front of the decimal? Yep, write it in front of the fraction, make it a mixed number. Okay, and write the 8 over its place value. What's the first decimal column called? The tenths column. Okay, this one's going to reduce. Maddie, can you tell me what it reduces by? And that's going to give us 2 and she's reducing by 2, by the way. You didn't hear what she said. 2 and what, Maddie? 4/5. 2 and 4/5. That's a really crappy way of writing it. Looks a lot nicer now. Okay. Questions? Most of your homework's going to have you do that tonight. There is a section on your homework that we're going to get to tomorrow that says ordering rational numbers. Now, when I say ordering, and that means from least to greatest. Now, when they're going to give you, you can see the problem we're going to do in our notes. They're going to give you a variety of fractions and decimals. And this is really going to not be your favorite thing to do. But the easiest way to order them is to write them all as decimals. It's really easy to compare decimals. It is not easy to compare fractions. Do you know why it's not easy to compare fractions? Because to compare fractions, you need them all to have a common denominator. And that's a lot of work when you have more than one fraction or more than 2 fractions like this one. Okay, so your best bet is to go ahead and write them all as decimals and then compare. 6.2 versus 8.74 or something like that. You can compare decimals very easily versus comparing fractions. We'll work on that tomorrow. You guys have plenty to get started on because you can not only finish your chapter 2 opener now from Friday, those 4 problems, because now you have notes, but then you can start all the other ones from 2.1 that are like this. So I'll see you guys tomorrow. Have a great day. We'll finish these notes tomorrow.
You'll see in the next 2 periods.
That's true. I will see you again. And you. And you. And you. Yeah. That's what I thought.